So I've got some of the basics of these wave file rendering things working. Before I move on and do a little bit more in the way of designing and cleaning up the code that I use for handling it, there's a little bit more I want to learn. So I want to stay in the very early exploratory mode while I'm already there and learn those things too. And I made these notes earlier back a couple episodes when I saw that there were floating point and other extensions that I might be interested in just because they seemed accessible to me and maybe potentially useful and at the very least just fun. So I want to look at extensions for floating point samples and for having more than 2 channels of audio in a file. That sounds like an interesting topic to go into. So I'm going to spend a little time reading the reference file again and looking for everything relevant to these floating points extensions first, and maybe see if I can convert some of my testing data, which is in 24-bit samples, into a file with floating point samples. Okay, we got floating point audio working there. I can't exactly show you the results because in order to put it into the video, I'd have to re-encode it. And so then what would it even prove at that point, right? So I will just skip showing you that it works, but it's the same stuff we were printing from the test program in the first place, except instead of coming out as signed 24-bit numbers, it's coming out as float numbers, but it sounds pretty much the same. One thing that turned out to be a little bit subtle about this is that the input format was in 24-bit 2's complement signed integers, and I don't have a built-in way in my language to deal with that, so I had to do a little bit of bit manipulation myself to actually implement the conversion from 24-bit signed integers to floating point signed integers. If you don't know much about 2's complement yet, I'm not going to go over it here, so this next part won't make any sense. But basically all I had to do to make this work is to first check the highest bit, so the 24th bit, or bit number 23, since they're 0 indexed in this sort of notation. And I had to check that bit and see if it's on. If it is 1, if that bit is a 1 instead of a 0, then I know that I have a negative number in 2's complement. But since I'm actually storing it in a 32-bit integer, since that's something the language can let me express, I need to extend it. And this is the phrase for this that you might see in other places is sign extension. I'm basically saying this was a 24-bit signed integer. I need it to become a 32-bit signed integer. So if it had a signed bit, if its high bit was 1, then whenever you grow it to a larger, wider number of bits, all of the high bits need to be ones after that bit to keep it having the same value and still being negative. That's all it takes. Check the high bit and extend it so that all the bits after that stay ones as well. So that's what I had to do there. From there, I can just treat it like a 32-bit signed integer who is guaranteed to be in the range of a 24-bit signed integer, and I do the divide down here that puts it into the floating point range -1 to 1, and that gives us our F32 from S24 buffer converter. Now I want to take a look at using more than 2 audio channels. Okay, so it looks like I got a WAV file working there with more than 2 channels. And in order to do that, I also had to get a parser and renderer for the extended header stuff, which wasn't quite fully fleshed out before. I mean, it still isn't fully fleshed out, but wasn't even being done in a very correct way. It's a little bit more precise now, got a better handle on that. So I think I've done a pretty good job of learning what's going on in the format for the parts that I'm going to be interested in using. So to take this any further, I think the next thing I have to do is pick a new path. What am I going to do next? I could pick more stuff to learn about the format, but there isn't much more about the format that I care about. I could learn about techniques of audio generation, since that's kind of where I want to take this for now. But I kind of am getting a little bit ahead of myself if I do that, I think, because I have all this code I've written, which was written in learning mode. And there's nothing wrong with using learning mode to learn something, but it's not a good way to write code. So I think the right thing to do is, before I move on, I want to go back over all of this a few times and do the passes that turn it from learning code into good code that I can live with for a long time. So I'm going to want to do a pass or two that upgrades things like its rigorousness. There are parts about it where I haven't actually rigorously followed what the specs say I should do, so I'm not necessarily generating things that are going to work in as many locations, as many interpreters as possible, and I could improve on that. I could also make my parser more likely to succeed even on broken inputs if I worked at it. So I want to upgrade those things to make it just work more often in more situations. And I also want to improve on the API design so that it'll be easier to work with these features that I have available, so that there's, access to the full featured stuff, but easy access to the common stuff as well. And I have some just code cleanup I could definitely apply as well. There are lots of places where I've already started taking notes of, hey, this code here got a little complicated. It's a couple helpers would really clean these things up. We have those swizzle and buffer conversion functions. So a bit of organization and improvement on those functions might go a long way. So I think that's what I'm going to plan on doing next. Is in the next video or two, I'm going to focus on cleaning up what we've got, do those passes that get this from learning code into code we can live with for a while. See you then.